Okay, case number 3, irreducible non-repeating quadratic. By non-irreducible, I'm talking about x squared plus 1 or anything of that form. We cannot factor further without going to imaginary variables. So the first example I'm going to do is x over x cubed minus 1. Okay, so in that case, again, because we have irreducible, you have to have the power difference must be 1, difference of 1. So my a, this is a linear, so in that case it's just going to be a. And then I have irreducible, we have bx plus c. In that case, because x squared decreases to x, and x decreases to 1, and 1 decreases to 0. Okay, if you have a regular quadratic like x squared plus 5, you cannot do it. You cannot do it. You cannot factor it. That's why you have to go through the same process of including bx plus c. If this were if it's a non-irreducible, non-repeating cubic function, then it would be x cubed plus whatever. In that case, it would be x squared plus cx plus d. Okay, so I go ahead with this. Ax, multiply everything out. So this one multiplied by the denominator, this one multiplied by this, and this equals to x. And then we end up with x squared terms. We have a plus b, which is equal to 0 because I don't have an x squared term here. And then in that case we have 0. That means a must equal negative b. Now next one here, a minus c might equal 0. That implies my c must equal a. But the one that we have left is x, which is x a minus b plus c equals 1 from over here. And then the 0 doesn't have it. So in that case we end up with a plus a is equal to 1 because we made a substitution. A equals c, b equals negative b, a equals negative b. And then you end up with this. So that means 3a is equal to 1. That means plus a equals 1/3, and b is equal to -1/3, and c is equal to 1/3. And in that case, we can rewrite this as a is equal to 1/3 over x minus 1, and b is equal to -1/3, which is this, and then plus 1/3, and then your denominator of the same thing. Now, you have to integrate this, so in that case, let's factor out the 1/3 out. And because I don't want to first forget about the negative and confuse it, so in that case, I'm going to keep it as add, but move this around. So you end up with 1/3, the constant terms over here, over 1 over x minus 1, and then plus 1 minus x divided by x squared plus x plus 1. Okay, now, because this part here is an easy one, you can just go ahead and integrate, and this is going to be a natural log, and this one here is going to be a little more difficult. So in that case, let's just say this one here, if you integrate it, ends up with 1/3 natural log of x minus 1 plus c1, okay? Because we have multiple integrals, my constant here will have, you have to label them. Okay, so now we're going to move on to solving 1 over x divided by x squared plus x plus 1. Now, looking at this, the denominator is nasty, but because it's a quadratic, you can use completeness squared. Okay, so in that case, we're doing this. This is very similar to the previous question we did. And completeness squared, you end up with 1 minus x, doesn't change. And then you have x plus 1/2 squared plus 3/4. Now, make another u substitution here. U is equal to this. You end up with x plus 1/2 equals u. And that implies du equals dx. And because we have an x here, we have to write as x equals u minus 1/2 from the question above, from the equation we came up with, the substitution. Now, let's substitute all the x's back in here and simplify. So that means this one here must equal, this is my u. Hold up. This is my u. In this case, u squared plus 3/4 of u. And then this x here is going to equal du. Okay? So in any case, this implies that simplifying this gives us 1/3, well, 3/2 u squared plus 3/4. And then minus my u from here. So this is u squared plus 3/4, and then it's du. So if we separate this into two separate integrals, so in that case the first integral is over here. So in that case we have 3/2, which is just a constant, so you throw that outside. And then you have u squared plus 3/4. Again, because looking at this, we realize this is going to be an arctan substitution. So in that case we have to change the 3/4 back into 1. So in that case, multiply everything by 4 in the denominator, and that means numerator you have to multiply by 4. And because of the 3, we have to factor the 3 out, so in that case we have the 3 over here. Okay? So in that case you end up with 4 over 3. In that case we want to put it back into my u, so in that case under the square, so in that case square root of 4 is 2, and square root of 3 is √3. So you end up with 3/2 times 4/3 times the integral of 2 √3 u squared bracket plus 1 And then we have to use a u substitution. In that case, changing up u, what do you use? U, so you use v. Okay, so v is equal to 2 over root 3 u, implying that du is equal to root 3 over 2 dv. Now, simplifying the cancelling, we end up with 2, and then my constant from, or the substituting back, we have root 3 over 2 times dv divided by v squared plus 1. And then simplifying this, v squared plus 1, this part here is just going to be the arctan. So we end up with root 3 from here, and arctan of my v. My v here is 2 over root 3 u, my u is equal to x plus 1 half. So make sure you make that substitution back. And then last but not least, c2, because this c here and this c here are different. So make sure you separate them by numbers. Okay, now second part here is the integral of u divided by u squared plus 3/4. So you ended up with making a substitution because this one doesn't have a u to the power of 1 term. So you can just use substitution. You have, let's say m is equal to u squared plus 3/4, and that implies dm du is equal to 2u, and then du is equal to dm over 2u. And then going ahead with this, substituting everything back in this equation, you end up with 1 half from here, and the u will cancel, and you're left with m. Okay, now 1 over m, if you integrate that, it's just going to be natural log. Okay, but make sure you substitute back m. M is equal to u squared plus 3 over 4, my u is equal to x plus 1 half. So make that substitution back in here, and then don't forget your negative and your 1 half, and then plus c3, because it's my third integral, and this we have to add a c each time. Now, overall, this is the question we're looking for. Okay, now we found this, and then we found this integral. Now we put everything here together, so that means it's 1/3 on the outside because it's multiplied for every single term. So it's going to be 1/3 times the first term, this part. And I dropped the c one because I combined it as c in the very end as just one c. Okay? And then b is equal to root 3 arctan of 2 root 3 x plus 1 half plus c2. In that case, this is going to combine with the c over here. And then my second equation here is going to be negative 1 half natural log of x squared, x plus 1 half squared plus 3/4, and then that's how I end up with this. Therefore, this integral here is equal to this. And that concludes the last demonstration of irreducible non-repeating quadratics. Okay, for repeating quadratics, irreducible ones, those are very difficult, so we're going to cover that today. I think I've assigned 4 questions, 1 from each type. So 1 for long division, 1 for completing the square, 1 for repeated linear, and non-repeated linear. Okay, there's one that's irreducible non-repeating quadratic, but that's a challenge question, you don't have to do it. So now move on to the handout and work on it. Okay, that's all from now. Thank you.